So we've got our piece of luggage, and if we draw a picture of it, sort of like a rectangular prism, and what I'm going to do is I'm going to start off with just thinking about this with actual numbers, and then seeing if I can use the actual numbers to create an equation for this. Sometimes creating a simpler problem can help us think through how we would do this with algebra. So to start off with, it says several models of carry-on luggage have a length 10 centimeters greater than their depth. So if I pick a random depth of 20, then if the length is 10 centimeters more, that would make the length 30. And if the total amount can't exceed 100, I can now just do simple math and say, oh, that would make this side 50. And that could be a possible piece of luggage that I could use, and I could do length times width times height to find its volume. Now the question is, we want to find the volume that's as big as possible. So switching around variables or switching around numbers will change the volume and make it either bigger or smaller. So now we have to introduce variables and see if we can come up with the same idea using algebra. Well, I just randomly picked 20. So I'm going to put whatever I picked there, that would be x. How did I find the 30? I found the 30 by just adding 10 to that x. Then finally, how did I find the 50? Well, I knew it had to add up to 100, so I did 100 minus 20 minus 30. If I do that same thing here and do 100 minus both of these, I'll put them in brackets, these together would be 2x plus 10. If I do 100 minus that, this becomes 90 minus 2x. So if you went to the algebra right away, sometimes we get stuck because it's complicated. If we go to a simpler example, we see what we needed to do, and sometimes that can give us hints on how to do it with algebra. Now that we have those dimensions with our algebra, we can say, well, the volume is just length times width times height, so I'd have 90 minus 2x times x plus 10 times x. And that creates an equation for our volume. This is going to be a technology question, but the graphing part you still need to know how to do using our skills that we learned for graphing yesterday. The skills that we learned for graphing yesterday were, right, if I want to graph, first of all, I need to know the end behavior. In order to figure out the end behavior, I need to know what kind of graph this is. Is it an x cubed graph? Is it an x to the 4 graph? Is it a positive one? Is it a negative one? So to do that, you can just look at your variables in each of your factors. Here I have a minus 2x, here I have an x, and here I have an x. If I multiply those all together, I would end up with a minus 2x cubed plus dot, 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 a bunch of other stuff. I don't need to know that other stuff for my end behavior because I'm just looking at, oh, it's x cubed, which makes it like a line because it's odd. A negative line looks like this, so there's my end behavior. For graphing, I also need to know my y-intercepts and x-intercepts. Y-intercept, easy, plug in 0 for x. Since this factor is 0, you will get 0, 0. And for your x-intercepts, plug in 0 for y, and what's really nice about this equation is that it's already factored for us. And so we've got 45, 0, negative 10, 0, and 0, 0. So with our end behavior and all of our intercepts, we have enough information to graph this. I'm going to go make these by 10, so this one here would be negative 10, 0, 0, 0, 10, 20, 30, 40, 45, 0. And behavior was here and here, and each of those x-intercepts has a multiplicity of 1, so your graph would go straight through, straight through, straight through. And so we can use our skills from yesterday's class to draw this graph. Now, the difference between yesterday's class and today is today we're looking at real life problems. Okay? So not only do I have a graph there, but I can say instead of this as y, this is v, which was the volume. And this is x, but x in this case stood for the depth or the height of our suitcase. And some things to consider in this equation. Not the entire graph makes sense. Can you have negative depth? No. Can you have negative volumes? Like, oh, my suitcase has a negative volume. You throw things in, they disappear. I don't know. That's possible. So in reality, only this section makes sense. Your depth has to be bigger, but it can't go past 45, because then your volume is negative. And what we want to try to find is this maximum. And to do that, we have to use technology. Either take out your phone and put Desmos on there, or take out your graphing calculator. I'm going to show you how you can get them with both. And it's a little bit tricky on both of them. So the first thing you're going to do, we'll do Desmos first. So we'll go to Desmos, you log on to Desmos, and we can type in the equation exactly as we saw it. So y equals 90 minus 2x x plus 10 and x. And we see the following graph. Does that look at all like the graph that we drew? No. Why not? Well, it's got the minus 10, it's got a line going down, it's coming through 0, but I can't even see 45. Okay? So one of the things you can do on Desmos is you can take your graph and scroll in and out. Like, and if oh, there I hit 45. So now I see a straight line going down, going through minus 10, coming back up through 0, coming back down through 45, but I don't see the nice curve that we had in our graph. What I want to see is this kind of shape, but right now I'm just sort of seeing a straight line here, a straight line here, and a straight line here. So what's happening with my graph is I'm not seeing enough y values. Okay? And the problem is if I just, on my computer, I just use my scrolling button, can you see that my scrolling button, yes, it lets me see more y's, but it's also, I don't need to see more x values. Like, I'm happy just to see from 0 to 50 here on my x values, but I want to see way more on my y values. So this can be done on both your graphing calculator and on Desmos. On Desmos, you need to go to the top right here and click on the tool button. If you click on the tool button, it says, what would you like your x-axis to be? What would you like your y-axis to be? I'm actually okay with my x-axis here, but my y-axis, I need to see a lot higher than 50. So instead of going up to 53, I could say, well, maybe 100 is enough. No. Maybe 1,000. No. Maybe 10,000. Closer. Maybe 100,000. Ah, there I see the top of my graph. Now, if you go up by tens, if you tried 50, then 60, then 70, then 80, this will take you a very, very, very long time. So we have to have a little bit of skills in guessing and checking. What we can do right now, there's my graph. I want to find the maximum. I can click on my graph, the dot automatically appears. It's at 36,209. So if you were going up by tens, that would have taken a long time. There are some things that you can do that can give you a hint of how high you should go. For example, if we go back to what we did at the beginning, we played around with real numbers. If you would go length times width times height on this one's volume is 30,000 centimeters cubed. So doing an actual example is like, oh, I shouldn't go up by tens. I know that it's going to be at least 30,000. So I probably would have gone, if I had done that math first in Desmos, I would have said, okay, in my tools, I know it's at least 30,000. Let's do 31,000, see if that's enough. Oh, it's not quite enough. And then went, all right, I'll go back, I'll do 40,000. Yay, it's enough. Click on that, find it, 28.6, 36,209. So on our graphing calculator, this is going to be very similar. But this time you're going to go to y equals, you're going to type in 10 plus x, 90 minus 2x, and x. And again, chances are when you graph it, this is what it will look like to start. So you're going to need to know a little bit about this graph in order to figure it out. And on your graphing calculator, to change your window, you hit your window button. So my x min, negative 10, I'm okay with that. My x max, I'm going to change to 50 so that I can see that 45. My y min, I'm okay with negative. Having a negative answer, make sure that you see your x-axis. But we already know that this should go up to 40,000 because the max is at 36,000. Now when I graph it, it gets that nice curve. On your graphing calculator, go second, calculate number 4, a maximum. It says pick a left value, so is the cursor to the left of the maximum? Yes, so push enter. Pick a right value, so I use my cursor to move it over to the right past the maximum. Push enter, it draws another arrow. As long as your maximum is between those two arrows, you can push enter again. And it finds the same answer at 36,209. Now this is a real cool application because this is very pertinent. Airlines make restrictions on luggage. If you're a manufacturer of luggage, you want to create the shape that has the biggest space. Especially, I don't know if any of you have flown lately. Every time you fly, they're like, oh, it's extra for this, extra for this, extra for this, but you get one carry-on for free. So if you can get as much stuff into that carry-on, that's a good thing. So they would want to be able to solve something like this to find out what should I make the sizes to make this as big as possible. Some other real-life application stuff. This answer, max volume, is 36209 centimeters cubed. Probably you haven't bought a lot of luggage in your lifetime, but when you buy luggage, especially if you're buying like high-end backpacks, you're planning on going on a backpack trip to Europe or South America after you graduate, you want to buy a nice backpack, you go to Mountain Equipment Co-op, and the backpacks, their sizes are all measured in liters. Have you ever noticed that? I don't know if you've ever shopped for backpacks. The reason they're measured in liters, not because you'd be like, oh, I can't wait to go home and fill my backpack full of water, but liters is a very nice way of converting measurements, especially in something that is not rectangular. Okay? So, first of all, if you have a 1 centimeter by 1 centimeter cube and you fill it full of water, it will perfectly fill to 1 milliliter. Metric system is wonderful that way. So having a volume of 36,209 centimeters cubed would mean that that suitcase could fit 36,209 milliliters. Most often, though, backpacks or luggage isn't measured in milliliters, it's measured 1,000 milliliters is 1 liter. So this backpack would be a 36 liter, or this suitcase would be a 36 liter suitcase. If you're trying to visualize how big that is, I like to use pails of ice cream. Pails of ice cream are 4 liters. This would be 9 pails of ice cream. You're like, I don't know, you're traveling home, you bought this suitcase, and you're like, I can fill it with 9 pails of ice cream and hope that it doesn't melt on the airplane. I think you'd be in trouble. I think it would start to. You can't bring liquids. But if it's in its solid state, is it okay? You're allowed to bring solids, but only 100 mils of liquids. Can you bring ice, but not water? These are
big food.
You can bring food.
Your luggage.
Yeah. You can bring snacks.
I've been flying wrong this whole time.
Yeah. You should snack it up. Yes. Okay. As long as those snacks aren't like Coke or Pepsi, but I wonder if it's frozen, if that would very probably. I'm not going to push it. I'm not going to be like, uh-oh, you have to go to that room. Yeah, don't want that. Anyways, so we're going to learn today that the stuff that we've been doing and the skills, there are some really nice real-life applications. We're also going to learn today that sometimes math textbooks make pathetic real-life examples. So we're going to do some awesome real-life examples and some pathetic ones at the same time.